Sounds groovy. We are looking at a little repo called juice-delegate-template. Boom. If you're looking at this, then you're in the right place, either on GitHub or in your code editor. So, let me think of a good starting point here. I think to pick up where we left off, so these are the three contracts I mentioned. We'll start, I'll just do a quick overview of all of them, of what's inside, and then we'll maybe take an audience hot take idea of what could we try, and we'll try to add it or adjust things. So this is the delegate called MyDelegate. It's mine. It's not yours. Yeah, don't try to take it. It's seriously mine. It's three things. It's the funding cycle data source, which means it needs to adhere. It needs to implement these two things here. First one is pay params. Second one is redeem params. If I didn't implement one of these, it would give me, hopefully, maybe a compile error. Oh no, I am in Forge land, thank goodness. I've been going back in V3 code and it's all like hard hat again. It sucks. Sweet, yeah, so I need to implement these two things for the data source to be, for this delegate to be a data source. This is because the on the other end of things, where V3 calls the data source, let me see if I can pull up both. I just ordered a new computer because this thing is getting old. Open V3 and close all these. Open editors. So the data source gets called in the token store. So payment terminal store. So payment terminal receives the funds. It tells its storage contract, payment terminal store, what should change. Like they should have less money. And the payment terminal store goes to check with the data source. How much less money should they have? And that is in pay params. So once the store gets told to record payment from the payer for a certain amount, here's a project ID, here's kind of the baseline number of tokens they should have given the discount rate and whatnot, beneficiary, etc. Go and get the funding cycle, make sure payments aren't paused and that there is a funding cycle. And then if the funding cycle has this use data source for pay flagged on, and it has a data source attached, then go to the data source and ask for pay params. And my response should be a token weight, so it's a multiplier, how many tokens should be minted, a memo that I'll post with the payment, and then those delegate allocations, so which delegate to call. And the thing we pass in is this data structure here called JB pay params data. And that has information about who's calling, so this terminal, payer amount, etc. So this stuff here, if the contract does in fact adhere to that standard, then it should, like that little bit that we just saw should hook in here, and you should get all the stuff back. You should then have the opportunity to give the terminal some info. Same with redeem params. In this case here, I'm returning, keep the weight the same. So the token weight that you thought you should issue, you should in fact issue that, and use the same memo that the payer passed in. Don't make changes to it. The thing we do want to change though is delegate allocations. We want to set the first item in that array. It can be many. In this case, we just want one thing. We want the allocation to be to this, and we're not going to forward any payments to that delegate. What you could do is revert some of the incoming payment into that delegate call. But in this case, we just want to call some logic and keep the funds in the treasury. Redeem params works the same way. So these are very baseline implementations. Does this first up top bit make some sense in how it's used in the protocol? Any questions? Okie dokie. So back to V3. What we're gonna do here is, so after you're gonna, the store is gonna do some math to figure out how much should I change the balance of this project, and then eventually it's going to do some math to figure out what's the token count, and then it's going to return to the main payment terminal. So this, I'm going to hop into this contract here and go to record payment from, which is that big block we were just in the store contract. So the payment terminal, which was the contract that received the payment in the first place, is going to expect the store to return some information. It's going to, like, which funding cycle was this payment recorded during? How many tokens should I issue? What are the delegate allocations that I received from the data source, which is this here, which is this here. And then from there, it's going to try to mint some tokens, which is its main job. That's its default Juicebox job. It's been there since V1. And then the next thing it's going to do is, if there were delegate allocations, then loop through them and send any money to them if that was the specification. Here's where the magic happens. Delegate did pay, and then you're going to send it some data that it packaged together here, so that the delegate also has context about what's been happening during this payment. Did pay, going back here, is implemented down here. So I included in this template a simple check at the top, which is what the NFT delegate uses, but it basically just makes sure that there's no forwarded amount. Like, this did pay function wasn't expecting any funds. So if it did receive funds, then this is not a correct payment. It's also going to make sure that the contract that's calling this function, did pay, the message sender, is a terminal of the project ID. So the project owner had to, at some point, specify that it trusted this payment terminal. And if it did that, then this contract is also going to trust that payment terminal and assume that whatever happens next, if it's minting NFT or if it's whatever, isn't being called by some random person. It's being called from a trusted contract, like a payment terminal contract. And it's also going to make sure that the project that the did pay function is being received for is the right project, the project that this contract was initialized with. For instance, I can't have a terminal that mints for that, like, receives a payment from one project and mints NFTs on a different project. That would be out of bounds. But you could not have the stuff, and then all bets are off. Like, anyone on the internet can call did pay. So it's no longer a guarantee that did pay is being called from the result of receiving a payment. This condition, it funneled it down to, like, okay, if you trust the terminal, then you're chilling. But you do have to trust the terminal, which also leaves room for people to build other trustworthy and creative terminals that also work with delegates. So this is a required piece of code to do anything particularly useful. In this case, all we're going to do, which isn't very useful, so you really wouldn't need all this, since we're not saving any new info or minting any NFTs, all we're doing is checking if payment from address is allowed, data.payer. If not, revert. Otherwise, then it just ends and regular operations continue. So you can instead allow list the beneficiary like this. You can whitelist both like this to make sure to make sure both the person paying and the person receiving the tokens are trustworthy for whatever reason. Yeah, that's kind of the basics. And that's and then the same thing on the redeem side, if you want. So that's the delegate contract. So I think that the bulk of the delegate map, when you think about like I do with these hooks in this file, fill up this question, and the spaces are separating concerns. So having one contract that's just this and another contract that maybe is this and maybe both of these, feel free to do that. The did pay, or rather the pay params, can just return whatever addresses should be called here. So it kind of hopefully gives you some illustration of how to navigate that. And I think apart from this, it's worth sticking here and just reflecting on like, does this templating and description help get some creative juices flowing? Is there an intuition as to, oh, okay, cool, this is how I might start implementing something? Or is it still fairly abstract and hard to make headway on, given current description? Because the rest of the files are more regarding how these attach to the project. Okay, cool. So is that a decent, like, okay, I grok what's going on, or I'd rather linger on this file if we need, because this is where like the others are one level higher up that probably don't need changing unless you're going for something really creative. This is where like the main stuff happens. But if we're like on the same page with how this works, then let's go to the next one. Okay. Okay. I'm just gonna go to the next one. Yay. Sweet. Delegate deployer. Guess what this does? This just deploys a delegate. So why is this bit interesting or cool? Usually when you're building a delegate, for example, NFT contract or Blunt or Defifa or anything, if one project uses it and another project uses it, they probably should be doing different things. Like usually a delegate storing data relative to a project. And its state depends on which project is calling it. Like one project is one NFT collection that's a delegate, and another project is a totally different NFT collection that's a delegate. Both of those are represented as these clones of a base implementation contract. So to save gas on those deploys, you write the contract once. I don't know like the nitty gritty of how this works on like the Ethereum opcode spec surface or whatever, but in general, you have one version of this implementation on chain, and then what you're actually deploying are clones or pointers to that implementation. So they have a separate address. They're just more lightweight to deploy. So this is what this does. And every time it does the deploy, it's just going to then call initialize on that delegate and pass the project ID that it's being initialized for. It's going to pass directory contract, which is a useful data structure. Like the directory, you can find like what are the payment terminals the project is accepting funds through, which controller is a project using to mint and manage its tokens. So that this is useful to have in your delegate when you're trying to do cool things. In this case, directory is only used by default to do that authentication check to make sure the caller is a terminal of the project. But you have access to a directory here if you need to do other stuff. And then it's going to go to, we have a common delegates registry, really simple contract that just keeps track of, since there's many of these delegates out there, like we want to know that this version of this contract is an instance of a particular delegate, right? So this is a well-known and understood JB NFT contract, for instance. And how we do that is one on deploy, there's a delegates registry that maps the new deployment, this new delegate we just deployed, to this deployer, which is a well-known address. There's only one deployer. So it's easy to cross-reference then to say like, okay, I can go to this registry and say, who deployed this address? And if it was registered, then it'll return the deployer address. So then a front end can, for instance, be like, okay, I trust this deployer, therefore I trust what it deployed. So that's useful when you start to then talk about like the trust layer of, okay, these are addresses on Ethereum that do arbitrary shit, and sure, the code is open and bindable or whatever, but that makes it just as easily to dupe people of what's actually real. So this is kind of a thumbprint that sticks around. Deploy delegate can be done by anybody, so you can go on Etherscan and do it. You don't have to do anything particularly special. You can deploy a delegate for any project. The interesting thing eventually is once you've deployed a delegate, you need to attach it to your funding cycle. The project owner needs to go in and just like it reconfigures payouts or token issuance, it needs to stick that contract in its funding cycle, referenced by this key called data source, which, the data source is all it knows, and the data source then knows the sequence of delegates to call. So it's this transient thing. And that gets done at this third contract, MyDelegateProjectDeployer. So from here, there's three functions. There's LaunchProjectFor, so let's launch a new project. There's LaunchFundingCycles.for, which is a function that we don't use currently, but if you already have a JB project lying around, you've never started funding cycles for it, you can use this to actually just launch your first funding cycle, and then there's a familiar reconfigure funding cycles of. These are pretty self-explainable, explain something-able. Launch, for instance, first it goes and finds what the project ID will be, which is just how many projects there are currently plus one. Then it's going to go to that delegate deployer we were just looking at and then deploy the delegate, pass in the project ID and some data that it received from the outside world. We'll look at this in a bit. And then a copy of the directory. And then it's going to call LaunchProjectFor, which goes to the controller. And this is the function called from the front end, for instance. It's a standard JB project launcher. The cool thing it's going to do in LaunchProjectFor is there's this data source address, which is the delegate. So after you deploy the delegate, you have a reference to it here. You pass it in to LaunchProjectFor. So it comes in here, and then you're going to bake it in. So all of these parameters, reserved rate, redemption rate, pause pay, pause distribution, pause redeem, like all the shit you can do, fund access constraints for like distribution limits, splits, which terminal should I use? All that stuff comes in from the outside world, from clients like JBM or Etherscan or wherever. The one thing we're going to guarantee is that the data source that's installed is the delegate that was just deployed. So this is like the max flexible. The only constraint is data source. But you can imagine like, okay, I actually like don't care. I always want to fix the reserve rate to this or whatever. And then you can start to limit the burden on clients by just constraining like what the hell is being configured here. And then there's similar calls for launch funding cycles and for reconfigure. The structures that kind of make all the magic happen are there's deploy my delegate data. Here's where you put information that your delegate needs. Like this is the variables that your delegate needs to do what it does. This deploy my delegate data gets passed at first into that project deployer. So launch funding cycles, LaunchProjectFor, deploy my delegate data. So this has allow list inside. And it sends that to DeployDelegateFor. Boom. DeployDelegateFor receives it, and then it initializes the delegate and sends it. Boom. Initialize here takes that same data structure, and then finally here it does. Okay, go through everything in the allow list and store it. So that's, if you want to add new functionality here that requires data from that initial deploy, shove it all in here. This is where, in an NFT context, this is where you specify your token URI, your initial quantity, your just everything that makes that delegate creative. And then this stuff is just standardized JB v3 standard shit. So launch project data is the other thing it needs. So LaunchProjectFor needs that delegate data and also needs launch project data. Launch project data, it just has the project metadata URI, which has the logo and the description and that stuff kind of set in the JBM create flow, for instance. Funding cycle data. So this is the scheduling information. So this is standard again in any JB launch scenario. Funding cycle metadata, which is all the stuff I was just going through in this big ol' chunker here, all this stuff. Splits, fund access constraints, terminals, and then a launch memo if you want. All standard stuff. So this is basically the requirements. And the cool thing about writing delegates from the perspective of launching and redeeming projects is you can also make cool creative choices as to like, what actually don't we really care about? Like, we know for sure we don't want pause payments. So let's not even put that burden on the caller of launch project. And I think like if we understand how this works from like this layer all the way down to the delegate layer, like the power is really in our hands to take this pretty open-ended protocol and do a lot of things and start to refine it and do like specific things really well and deploy them in various environments. It's all in here. And then the cool thing about Defifa, I'm going to stretch it one degree further because it's exciting. The projects like Defifa take this one step further and make the deployer the actual owner of the project. So not only is this deploy a project, it also is the owner. So it also keeps track of a series of other funding cycles that it's going to auto schedule. So maybe hackathon next month or next whenever is a project owner hackathon that maybe stretches things in that direction. And if you're building a client, this repo might also be somewhat useful just to get a sense of the data that needs to be passed. But there's probably other starter client code bases that we can make useful to folks that maybe plug in nicely to something like this. How we doing?
This is great. Super helpful.
Hell yeah. I think the thing that I want to build this week involves in LaunchProjectFor, like also pass in an array of these reconfigure datas. So you can launch a project that also says, okay, this is like, here's my launch data, but then also here's like the next 3 reconfigurations you should know about. And then it stores it. And then it's kind of just queues those up so that when you're in a current one, and if there's there's something queued, then it will auto configure it. And then it hooks into some delegates in a neat little way. Cool. All right, well, let's get hacking then. I'm gonna end yeah, cool. It probably won't be too online this evening. I might be around every now and then, but tomorrow, this is like any questions that come up regarding hackathon. I think we should have a good space here, but also there's a Telegram for it. If I'm not around to explain to some Buidl Guild hackers or share ideas, I definitely trust you all to at least broad strokes it, and kind of share the getting started circumstance. I'm looking forward to just being. I'm going to try to be in Banana Station often, screen sharing and just playing with these things. So come through and ask questions and get weird.
Great. Any questions from anybody? Any last comments, questions?
All this stuff looks cool.
Let's go. I think it's really cool too. I really like my brain gets pretty excited and like empowered when I think of like all the shit we can build. But it's I feel like just getting to that moment of, okay, if we create a good enough JVM where it can be reactive to this unknown possibilities of what people can do, and then maybe create like a queue of like, oh, you have a good idea, like let's try to just adapt the project page slightly to make that work. But it's like less barrier because you don't have to make like a whole new front end or stuff like that. But you can still articulate some pretty wild, far out stuff. Pretty exciting. So great to kind of focus on that first moment to try to get to that aha moment for more folks. Because having this at your fingertips it's pretty neat, and it's definitely not like a contract crew oriented thing. I think a lot of the work we've all done as more contract crew oriented for the past couple of years is to get to moments like this where you can expose a lot of functionality with very little risk as to what you're doing. Like if you can understand those funding cycle parameters, then you can program a treasury without opening much risk, as you were saying earlier, Matthew. I think like you can keep things simple and trust that like, okay, if I sequence things this way, then you're going to get these outcomes. So hopefully we can make these tools more accessible to folks, while also recognizing that we shouldn't all be contract engineers and feeling pressure to go through the whole rigmarole of testing and verifying like everything. I think there's definitely value in having like I would love a hackathon of how to stitch together a 5-minute video explaining how something works, because goddamn, that stuff also looks juicy, and I bet there's some cool tools to be shared and leveraged, and websites too. I think like lowering the barrier to entry for building websites that hook into these things would be great.
Ken asked in the chat, can we trigger from Octane API? Yeah, maybe if you could explain a little bit more about your question there. Are you asking if we can trigger like pay functionality or something else?
If we had another process running somewhere, I mean, this is the use case, right? We've started up this festival and now we're starting to sell tickets, and I would love to be an on-chain record when people buy tickets to the festival. So how do we bridge? We have API access to, obviously we have our database of users as people are buying. So that's just something where it's like, obviously the volume's small, so we could do it manually and that would be fine, but it'd be cool if it was automatic. That makes sense?
Yeah, I think it's interesting. It's like you definitely need a wallet to pay the gas to interact with the thing for the first time, at the first payment. I think, I'm trying to consolidate both what you're trying to get at, which is necessary, but also the scope of a delegate-based hackathon. I think there's something there, but I think more than likely having a token issuance, like one transaction to issue and like an owner operator, like a bunch of tokens, it's then going to account for or distribute is probably more worth it than to send in a pay transaction for each of those moments. You just want one big like batch mint, and then you can run the accounts on your centralized like matcher of like, okay, I got a credit card payment in here, And so I'm holding on to 10,000 green light power tokens on its behalf, which I have custody of through that one transaction. I don't think you need to match each of those credit card payments with like a tick on the blockchain. There's some like kind of middle layer there that's probably what people are going to be paying for in that moment.
It makes sense.
We should definitely do that. Like I think the barrier to that problem, I think, is just like the willpower to account for such delicate things. Because you can always do it retroactively too. You can always like run your accounts later and be like, okay, 2 years ago we got these 10 payments, and so we're gonna give them access to X tokens if they want.
We could totally do it weekly.
So forward acting, it's like, okay, no, we have a weekly process where we run the accounts, we mint new tokens, we allocate them or account for them in a certain way, and then we go on the next week. Like that's like power, because that's when people go and audit that, like your customers go and audit that, they're going to see like, oh shit, they had my fiduciary interest like way before I did, and that's people I trust.
That's cool.
Tight. All right, I'm bounce. There's no more questions. Shouts to Based, who posted in the thread adding NFTs to Buidl Guidl projects. Maybe we should consolidate threads though. So we're not. I think the Delegate Hackathon channel in the juice topic of the Juicebox DAO server is the current most best official place to post your curiosities and questions and intrigues. And big brain folks like Based and Dr. G and others will be perusing. So bring the spiciest of questions and screenshots and demo videos along the way. And we'll figure out how it plays between that channel and the Telegram later, but excited for it. Maybe tomorrow or someday this week, someone who's written a delegate, Based is working on for Banana Puss, Dr. G is working on one for Buyback Delegate. Maybe we can do deep dives on those cases tomorrow, or for whoever's interested, maybe as inspiration or just as kind of insights. That could be a fun series for the week. Could do Defifa too, stuff like that.
Yeah, I'd also love to record those if we could. I can turn them into some videos for reference. I think it would be really helpful for, DevRel.
It's an amazing idea. Sweet. Alrighty, y'all. Cheerio. Big love.